All right, my people, here we go. We got another rectangle problem here on the left with a few expressions and two capital letters, A and B. And this is a rectangle. So hopefully we know the 7 properties of a rectangle and how to apply them. And so what's the goal here? The goal here is to find x and y. That would be nice. And then after that, we are going to find the length of AB. The length of AB is one of the diagonals. And if you know the properties of the diagonals, the properties of a rectangle, it turns out the other diagonals are going to be exactly the same. So either one of these diagonals will be the same, the length of AB or the length of the other diagonal. So just keep that in mind. So how do we find x and y? So let's look around, see what we see. So it looks like we have an expression for a few angles. This is an angle. This is an angle, that's an angle. So hopefully we can kind of connect how those angles are all related and come up with an expression. All right, what else do we see? Well, this is some expressions for the sides in here. Notice there's an expression for one of these sides and an expression for one of those sides. So we have x and y's everywhere, and we also have expressions for sides, expressions for angles, and so forth. So how are we going to connect the properties of a rectangle in order to determine what equation to write to solve for x and y? Well, one of the properties of a rectangle is all 4 angles are 90 degrees. And if you notice over here, it turns out those 2 angles have to add up to be 90 degrees. Those are complementary angles. But that's a little awkward right now because we have 2 variables at that location. All right, so let's keep on hunting around. So how else are these angles related? Well, I see vertical angles. If this is x plus 20, hopefully you're seeing that this angle is x plus 20 right in there. That's nice because now I'm starting to see a little triangle pop up in here, and I know 2 out of the 3 angles. And so if you keep on thinking about the properties of a rectangle, hopefully it just snaps right into your brain that the lengths of these diagonals, not only are they congruent, but the diagonals also bisect each other. And so when the diagonals bisect each other and they're congruent, this produces this incredible triangle in here. And hopefully you can know the language of that triangle. The language of that triangle, that is an isosceles triangle. And so right away, once you see an isosceles triangle, you should be thinking, yes, I know something about the sides, and then I know something about the base angles. Well, if this one base angle is 2x minus 30, then the other base angle must be 2x minus 30. And so then, let's go back and highlight this triangle. One other geometry concept that we've learned over and over again throughout this whole entire book is, you give me a triangle, it's going to add up to, all 3 angles are going to add up to be 180 degrees. So since we know expressions for all 3 of those angles, let's write an expression. This is going to be an equation. X plus 20 plus 2x minus 30 plus 2x minus 30 equals 180. So let's solve for this. We got 2x and 2x and x, that equals 5x altogether. And then I got negative 30, and a positive 20. And so when I bring that on the other side, that's going to be 180 plus 60 minus 20. It looks like that's going to be 220 when I solidify all those numbers. And so 5 goes into 220 how many times? It looks like 44. So we're getting close. We have found x. X turns out to be 44. So we can find some angles now if we wanted to, but we don't have to find any angles. We just want to find, excuse me, I misspoke. We found x. So how are we going to use x to maybe perhaps find y? So let me clean up this picture a little bit and try to showcase where y is located. Well, I have an expression here for y, and I have an expression here for y. And so notice one of them is an angle and the other one is a side. And so since we just found an x to be 44, I can back substitute and I can find this angle in here. And why would that be nice is because I know how those two angles are related. Those two are complementary angles. So if we back substitute and go 2 times 44 minus 30, this angle right here turns into be 58 degrees. That's the green one right there. That's 58. So the complement of 58 is 32. So bingo, we just discovered y now. Y turns out to be 32. Well, if y is 32, that angle is 32. Not only is the angle 32, the value of y is 32. So we can deduce that this side is 32. And since we found x to be 44, this side would be 44. So unlike some previous problems where we had to find the perimeter, we're not trying to find the perimeter here. We're trying to find what? We're trying to find the length of the diagonal. And where is that length of the diagonal again? It's right there. So hopefully you can see how we are going to find the length of the diagonal. Remember, the length of the diagonal is not an angle. It's actually a side. So now we've got to kind of have to start thinking in terms of sides. Since AB is a side, we know some other sides. What other sides do we know? We know 44, and we also know y was, I think we said 32. So I'm going to highlight that side. And so all 3 blue sides are highlighted here. And why would I use all blue in there? Hopefully you can see what I have just highlighted. That is another right triangle. So in a few shapes that we're talking about in this chapter, there's lots and lots of right triangles. So as we finish up this problem, make sure you know how to apply all the properties of a rectangle. And another helpful question is, do we see any right triangles? Well, we see right triangles are rectangles, rhombi, square, and hopefully you can see how we've just used that blue triangle to showcase a right triangle, and then automatically, as soon as you know you have right triangles, you should be like, yes, I can discover any length of any of the sides by using Pythagoras. So if I were to redraw this triangle over here, 44, this is 32, and now I'm just going to make up a variable in here. I'm going to call this W. W is going to be representing the length of AB. So lots of times all of our answers are nice whole numbers, but on occasion they turn out to be decimals. And if we didn't use our calculator, we would have to leave it in radical form. I'm going to choose to use my calculator here and try to get an answer. I'm not sure at this stage whether it's going to be a whole number or a decimal, but we're going to find out. But we can certainly use Pythagoras right now to solve this problem. So when we set up Pythagoras, let's do that. Let's going to go 44 squared plus 32 squared equals W squared. Notice I put the W squared all by itself because when we set up using Pythagoras, the hypotenuse is always going to be by itself. So what do I know? I know 44 squared is 1936, and then I take that and add it to 32 squared, and I'm going to get 2,960, and then I take the square root of that, and it is not a nice whole number. It's not a big deal. What does W turn out to be? W turns out to be 54.4058. Okay, I chopped off a few decimal places there. But that's good enough for now. That is the length of W, and if that's the length of, if that's the length W, that's the value of W, then the length of AB is going to be 54.4058, and that is the length of AB. So this is really intense. We have properties of rectangles. We don't tell you which property to use. You just have to kind of see the picture. You have to develop a sense of what property is going on in here. And then when we draw on diagonals, then we create all sorts of triangles. Which triangles? As you can see in this problem, as we summarize here, we use this triangle down here, and that happens to be an isosceles triangle. Not an isosceles right triangle. That's just an isosceles triangle. And then the blue one that we discovered was a right triangle. And when we have right triangles, then we're allowed to use Pythagoras. So Hopefully you learned something in this video, and check out the next one.